Gas is held at constant volume, which is important because then we know that we can use Gay-Lussac's law. I think up here, I ended up doing 3 atmospheres because there's these values right here, but we'll have to change that because it's meant to be 2. And we get told the pressure is 699 millimeters of mercury. So this here actually stands for millimeters of mercury. So the way it works, the way they do pressure measurements in that is what happens is they have your gas in like a canister kind of thing, and they link it to liquid mercury. Okay, so from module 1, one of the things we learned that the two liquids at room temperature are bromine and mercury. Okay, so mercury looks silver, it's quite heavy. I don't know if your teachers ever brought it out for you to play with, but my teacher did once and it was quite fun. What happens is that if the gas expands, because it's a liquid, it's able to push back and forth. Okay, so if the gas expands, then the liquid pushes down this level, and then if the gas contracts, then your liquid can expand a little bit further up here, for example. Okay, so what they're measuring is the length of the mercury inside of that tube. So that's why it says 699 millimeters of mercury. And that's just another unit for temperature. And once again, another unit for pressure. And once again, whatever unit it is, you can use that since you're relating 2 different points together. So it has a pressure of 699 at 40 degrees Celsius. What is the temperature of the gas at standard pressure? Okay, now standard pressure, okay, is 1 atmosphere. Yeah, so standard pressure is defined as 1 atmosphere. And another conversion for you to know is, earlier I told you 1 atmosphere is 101,325 pascals. 1 atmosphere is also 760 millimeters of mercury. Okay, so they tell you that at one point, 699 millimeters of mercury is 40 degrees Celsius. Then they want to ask you, what's the temperature at standard pressure? It kind of looks like they've only given you 2 numbers, but they have given you a third because standard pressure is defined at 760 millimeters of mercury. Okay, so in this case, we have P1 on T1 is equal to P2 on T2. What's my P1 in this question? So it'll be 699.0 millimeters of mercury. And what's my T1? Beautiful. And what's my P1? I'm sorry, P2, I meant.
P2 would be 1 atmosphere.
Yeah, and because I want to be able to cancel out my units, I want to have it in the same unit. Otherwise, I need my unit to cancel out because I'm only looking for temperature in Kelvin. So what's 1 atmosphere in millimeters of mercury?
It was 760.
Yeah, okay, so I need to have it in the same units because otherwise I won't be able to cancel it out later. So I need to have this as 760 millimeters of mercury, and then I'm looking for T2. Okay, so what's my equation now? How do I look for T2?
That would be 340.4778.
Okay, and what units is this in? My temperature, Kelvin, good. So I originally had this in Kelvin. My pressure was in millimeters of mercury, and this was millimeters of mercury. So when I cancel these out, I just get left with Kelvin. So let's say, for example, the question wanted you to convert it back to Celsius. How would I do that?
You would just minus 273.15 from that.
Yeah, so it would just be minus 273.15 to get it into my Celsius. All right, beautiful.